Imagine a critical server suddenly goes dark, bringing down a website or a vital service. What if there was a way to prevent such catastrophic failures from ever impacting users? This is precisely where a powerful concept in system design comes into play. Hardware redundancy in system design is the practice of duplicating critical hardware components or entire systems to ensure that, if one component fails, another can immediately take over its function without interruption. It is a cornerstone of building highly available and fault-tolerant systems. The core mechanism behind hardware redundancy is eliminating single points of failure. When a system relies on only one instance of a component, like a power supply or a network card, that single component becomes a bottleneck for reliability. If it fails, the entire system can fail. By adding a redundant component, you create a backup that can seamlessly step in. This significantly reduces the mean time between failures, or MTBF, for your overall system, meaning it will operate reliably for much longer periods. So, how do engineers put this into practice? You will often see redundancy applied to components like power supplies, where two are installed and both are capable of powering the system. If one fails, the other picks up the full load. The same principle applies to network interfaces, disk drives in a redundant array of independent disks configuration, and even entire servers or data centers. Modern systems often use configurations like N+1, N+M, or 2N redundancy, where N represents the number of active components needed, and the additional components are spares ready to activate. A key aspect of effective hardware redundancy involves designing systems with hot swappable components. This means you can replace a failed part, like a hard drive or a power supply, while the rest of the system remains operational. Furthermore, robust redundancy systems include automatic failover mechanisms, which detect a component failure and switch to the backup without manual intervention. This ensures graceful degradation of services and minimal downtime. By strategically implementing hardware redundancy, system designers create infrastructure that can withstand unexpected hardware failures, maintaining continuous operation. This commitment to reliability ensures that services remain accessible, transactions are processed without interruption, and user trust is consistently upheld, all contributing to a robust and dependable digital experience.
If this helps you code smarter, like, subscribe, and stay tuned for more.